Hi everyone, so in this video we're going to look at 0 to the power of 0 with my friend Hippo. And the way we're going to look at it is simply to use index laws. So if we take 0 to the power of 0 and multiply it by 0 to the power of 0, well, what does that give us? The bases are the same, so we can just add the exponents. So it's going to give us 0 to the 2 times 0. 2 times 0 is 0, so it just gives us 0 to the 0. Now we don't know what 0 to the 0 is, so I'll call that x. So let x be equal to 0 to the power of 0. Well, then we can just plug that x in here, and we have x times x, or x squared, is equal to x to 0 to the power of 0. So that's, and we're calling that x. So we just get x squared is equal to x. And from that, we get x equals 0 or x equals 1. But we can keep doing this trick with the index laws and add on as many zeros to the 0 as we want. For example, if we did 5 of them, 0 to the 0 times 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 0 to the 0, that's going to be equal to 0 to the 5 times 0, again, equals 0 to the 0. So in that case, what we're going to get is x to the 5 is equal to x, or x to the 5 minus x is equal to 0. We'll factor out an x, and we'll get x squared minus, or x to the 4 minus 1 equals 0. And then we can use difference of squares to factor this part here. So we get x squared minus 1, x squared plus 1 equals 0. And that'll give us x plus 1, x minus 1, and we'll leave, well, we'll just write it as x plus I, x minus I. And this will give us x equals 0, x equals plus or minus 1, and x equals plus or minus I. So in fact, in answering the question, can 0 to the power of 0 be imaginary? In fact, it can, because here we have this x to the 5 is equal to x that comes straight from this. And that will give us complex roots I and minus I. Now, if you're still watching this video, you'll realize that what I just said is incorrect. And the reason for that is that we have to satisfy all these equations. So we can have x squared equals x, x cubed equals x, x to the 4 equals x, x to the 100 equals x. Actually, if we want to solve for the value of 0 to the power of 0, every single last one of these equations must be satisfied. So here, when we have x to the 5 is equal to x, yeah, sure, I and minus I are roots to that equation, but are they roots to this very first equation? No, the only roots we have to this first equation, x squared is equal to x, is 0 or minus 1. So straight away, we know that the only possible values for 0 to the 0 is 0 or 1. And you'll notice that no matter how many, x to the 100 is equal to x, 0 will satisfy that equation, and so will 1. So therefore, really the only candidates for this value are 1 or 0, and they can't be it can't be both. Exponentiation is a function. So that's why we tend to say that 0 to the power of 0 is undefined. Whee! Whee! Bye, everyone.